the end we thank everyone, but last night we thanked everyone. The thank yous are all done, okay? So if you weren't here, I'm sure you'll be told that I did indeed thank everybody. So you're very welcome here this morning, and I must say this is a continuation of our festival of lesson study. And last night we got off to a marvellous start. There's just a few things I want to say to you, and that is that the posters that are all along at the tea and coffee, you should really have a look at them, because you can see from them maybe which lesson you want to go to see. And you will see that the teachers refer in them to all the national priorities the lesson study has integrated for them in a very meaningful way. So if we could just focus then on today, you've done your registration, this is your welcome. And Tad is going to be coming in to continue his third lesson with the group of students from RD Community School. And they are a higher level group because with Storm Emma, the group that were going to come couldn't come today and so on. So that is different to the schedule you would have got. But Tad will be coming in, and in a moment I will go through the lessons he's already taught with the students. And then you have the poster presentation and exhibition down where the tea and coffee is. And if I could just make an announcement that anyone who taught the lesson in their school, at the end of the day, you are welcome to take your poster down and bring it back to the school with you. Now, that's not an invitation. Anyone can take any poster, okay? If you taught it in your school, please take your poster with you. Could I then say the live lessons? It's in your pack what the live lessons are, who's teaching them. One of them is from RD Community School in County Louth. The second one is from Coláiste Éamon Rís from Callan in County Kilkenny. And the third one is all the way from Bandon in County Cork. So they were certainly up early this morning, Coláiste na Torbatha. So they're the three lessons, and in your conference brochure it tells you what each lesson is about. We have lunch then from 12:30 to 1:30, and this is a change from our previous, because with the storm the rooms here weren't available. So in the afternoon for the workshops you'll have to go out behind to the Health Science Centre, but it will be clearly signposted for you. It's about 3 or 4 minute walk, but we are intending to start on time. So the lunch, if you could, maybe by 20 past start moving out. And then last but not least, we have our own team leader from JCT, Shane Flanagan, and Shane is kindly going to give us some insights into the new junior cycle maths. And that will be the close of our conference. Just a few things to say. I hope you put in, and again it was in your conference pack, your application to be able to be in with a chance, thanks to Microsoft, new Microsoft Pro with all the accessories. And we'll be announcing the winner of that. It'll be drawn out of the hat this evening by our friend Mr. Bill Lynch, and you will be notified who has won. Okay? It's not a case of, well, we'd like you to be here to accept it, but if you're not, it doesn't mean to say you won't get it. We'd like you to do a bit of tweeting. I believe there's a prize for tweet of the day. Okay? So be as imaginative as you can. And again, don't forget that on your pen drive you have over 70 research lessons produced by all the teachers around the country on your pen drive, okay? So you have that available to you. And just to say, for your information, you also have in your pack our latest publication. It hasn't gone to the schools yet, on inferential statistics for means. And just as, again, a point of information for you, it's timely that we're meeting today because that's the last time our logo will appear on a publication. We have joined the PDST, and just for your convenience and the transition period, we kept the logo there, but next year all your support will be from the maths team within PDST, okay? So just that you're clear on that. So this is what Tad has done. These are actually the goals of his lesson, fractions and their curious behaviour. And he wanted over the 3 lessons to achieve these goals, that students would understand that algebraic expressions are useful explanation tools, that students will extend their ability to add and subtract algebraic fractions, and finally, that they will continue to develop mathematical proficiency. So they were his goals for the 3 lessons. The first lesson taught in RD Community School yesterday morning, I'll just let you read that for yourself. They were the goals of that lesson. Okay. Last night, this is what they moved on to do. So that is what Tad did last night, okay? So if you could, and I think they're out there, want to welcome you now to Professor Tad Watanabe. And so Professor Watanabe was with us 5 years ago, and I know he struck a chord in all our hearts. He's back again, and here we have the 5th year Leaving Cert students all the way from RD Community School in County Louth. So if you could all give them a huge welcome, please.
More coming. just. Oh. So can I, whoops.
The rest of them are coming. There are about 25 or 6 of them. Where did they go?
They went to put the bags.
Oh, here they are. Another round of applause for the students from RD Community School. Come on in. Okay, and we have to be mindful of the fact that without the students volunteering to come here today, we would have no demonstration lesson. So I think we applaud them for that.
Four. Oh, it's okay. I guess we have seats. Okay, good morning. Yeah. I'm glad you came back. So I want to just go ahead and return the reflections that you wrote for me. I can't see. All right, so this sounds like a normal class. Neve, where are you? Niall? This is yours, right? Megan? Okay. Trevor? Donna? So is this Kiara? Kiara? This Kiara? No, C-I-A-R-A. She's not here, but that's Kiara.
Kiara, yeah.
So C is pronounced as K. So this is Karen? Yep. That's yours, right? Yep. Cathal. Yep. Teresa. Oh, so it's Teresa. Oh, no name. So you're going to have to.
We'll find out now.
Yeah. Durian. That's Durian, right? Durian. Okay. Aisling. Ashling. Okay. Ella. Cameron. Ryan. Kevin. Anya? This is how you spell Anya? Wow. Jenna? She's not here. Okay. Sarah? Brian? Laura? Dara C. Jasmine? Delton? Michelle? Dara Myers? Eileen? Grace? Tara? All right, so who was that nameless? Stephen. Okay. So I didn't put any comment on, but I enjoyed reading your reflection. Few things. Oops.
This is your turn.
Would it work? Okay. So how do you get rid of that?
Click out on the screen.
All right. So I noticed a lot of people mentioned that it's surprised to learn that there are infinitely many fractions between two. Right? We talked a little bit about that, right? Because we can keep creating new fractions in between. Some people said that determining whether the difference was positive or negative at the end was a little confusing. And it's something that, you're going to have to get used to. You keep doing many of these kinds of problems and you start using reasoning, things that are not explicitly stated, but you have to try to reason it out. And you start doing more and more of that as you take more math courses, right? And one person, I can't remember who it was, mentioned that the lesson made you think outside of the box. And a lot of times when I teach classes at my home college, some students tell me about thinking outside of the box. And I tell them, thinking outside of the box it's great, but it's hard, isn't it? So my goal is to really try to help you expand your box so that you can still think within the box, but you now have a bigger box to think inside. Okay? So that's what we're going to try to do a little bit more today. Okay? So, which is bigger? What? Oops, where's, oh.
Do you want me to do that?
Oh, yeah, sure.
Oh, okay. So just put your hand and I can give you the mic. Who spoke?
Do you have any idea which is bigger?
Who spoke?
Tara.
No,
Tara.
Tara.
Oh, you want to use calculator? Go ahead, go ahead.
Tara's asked, can we use a calculator?
Go ahead and use calculator. I mean, you might want to pair up and one person does one and the other does the other, because you end up with fairly long decimal numbers. What'd you get?
I think they're the exact same.
They're the same? So are they equal? Yeah? You sure? So they're equivalent fractions. Right? Equal means they're equivalent, right? Right? Yeah? So you can make one into the other by multiplying or dividing both numerator and denominator by something. Is that possible? Now, anything else you notice about those two fractions? Denominators are different? Sorry,
You're okay. Sorry, it's really hard to coordinate this.
yeah.
I don't want to be in your way at the same time. So you said
The denominators are different.
Okay. Anything else? What?
Ryan.
The numerators are also different.
Okay, so the numerator is also different. How different? All right, so I hear several voices, but
Okay, so could we have one voice just pass it around there? Can you see it?
The numerator in both of them is the right one is just adding one on, but it looks like the denominator is
okay,
also
so
adding one as well, so it kind of cancels itself out.
oh, okay. So this is one more than that. This is one more than that. And so they cancel out and they're equal. All right, sounds great, right? So let's see if that works, right? Start with some very simple fraction. So if you say start with 1/2 and add 1 to both numerator and denominator, we can make equivalent fractions. Some of you saying no. No? Huh. Maybe it's true with that one. No? It just didn't work with this one, but maybe it works with that one. Maybe? Do you think there's any, so how would you write this using algebraic fractions, this relationship? If you're given a fraction, so any fraction, how would you write this sort of any fraction using algebra? A over B, right? And we're comparing that with after you add 1 to both. So A plus 1 over B plus 1. I wonder if there is any kind of relationship between there. Can we say one is bigger than the others or less than the others? How would you test that? Yeah, somebody said that? Okay.
Yeah. Is it like yesterday where we subtracted them?
Like what we did last night?
Yeah.
What do you think? Sounds reasonable? So you subtract one from the other and see if it's going to be positive or negative?
Yeah.
All right? So see if you can figure it out. Okay? Since you guys sit on the ends, can you each show what you did? So Laura, you can write yours here. And Darren, you can write on this side. Okay, great. Great. Thank you. Thank you. Thank you. All right. So what do you see? Do you see any difference? They do exactly the same thing? Some says no, some says yes. What do you think? They do the same thing? There's a follow-up question. So what's different?
The sign on the numerators are flipped.
Okay. This?
Yeah, that's B minus N and then minus B.
Okay, but what do you think? Where did that difference come from?
Which you're like whatever's been taken away.
Yeah. So this is Laura's.
Yeah.
And this is I can't spell that. Darren. D-O-I-O. Can you spell it for me? I'm getting some Gaelic lessons. Okay, thank you. So what's the difference between Laura's and Dorian's? What did Laura do? Oh, I guess go ahead. You have a microphone.
In Laura's, it's the A plus 1 over B plus 1 take away A over B, and then it's the other way around in Darren's. So the signs are different.
Yeah, so they're opposite, right? So if you put a negative sign in front of one, you should get the other one, right? So they really did the same thing, except the difference between 5 minus 3 versus 3 minus 5, right? One gets 2, and the other one gets negative 2, right? So did they do this calculation correct? Yeah? So what's the conclusion? Why were we doing subtraction? To see what?
To see which is bigger.
Oh, to see which is bigger. So which is bigger? Oh, good.
Well, we don't know because we don't know if A is a larger number than B. Okay. So
one thing I forgot. Let's just say A and B are both greater than 0, right? We're just assuming that same thing that we were yesterday. Is that enough?
No, I still don't know which is bigger.
Oh. So what do we do? Can we say the denominator is positive?
Yes.
That part is okay? So it's really trying to figure out B minus A or A minus B.
Yeah, I don't know.
You don't know?
No.
Anybody with idea? Do we know anything about A and B? They're positive. Do you know which is bigger?
Would it be B? Would it be B because it's the denominator? So usually it's not a top-heavy fraction, is it?
Oh, okay. Does it have to be always top heavy or the bottom heavy?
No, but
So what makes the difference? What do you mean by top heavy? Hold on.
The numerator is greater than the denominator.
Numerator is greater than denominator. So in this case, if A is greater than B, that's top heavy. Do we know anything about that? About these two, the fraction, the given fraction? It can't be either, right? I didn't say anything. So if we know that, we can decide whether it's positive or negative. Yeah? So if let's say if A is greater than B, then what can we say about this? So if A is greater than B, this B minus A is going to be negative? Negative? Michelle, you okay? Negative? Yeah? And here, if A is greater than B, A minus B over B squared plus B is going to be positive. So either way, what's the conclusion? Which fraction will be bigger? A over B or A plus 1 over B plus 1? So this subtraction gave you a negative. That means which is bigger, this one or that one? A over B. So this means, oops. So this means A over B is bigger than A plus 1 over B plus 1. Do we get the same results on this one, conclusion? So A over B is greater than. Well, that's if A is greater than B, right? So this is A over B is greater than. But so if A is less than B, what happens? So if A is less than B, what can we say about B minus A over B squared plus B? It's positive there. And in this case, if A is less than B, A minus B over B squared plus B will be negative. Right? But either way, we get the same conclusion. Which fraction is bigger, this one or this one? This is bigger. So is it okay to have these cases? Yeah, right? Well, there's one case we haven't seen yet. If they're equal. What happens if A and B are equal? What do you think? Equals 0? Oh, this difference is 0, right? Difference.
If A equals B, well then B minus A will cancel and be 0 on top.
The top will be 0, so the fraction is going to be 0. So what's the conclusion about those two fractions?
That they're equal.
They're equal, right? So adding 1 to both doesn't change. I mean, if you think about some concrete example, like if you start with 3 over 3, right? That's A equal B, right? Add 1 to both, you get 4 over 4. Add 1 to both again, so you get 5 over 5. It doesn't change, right? So those are the 3 possible cases. So unlike yesterday's case that we only had given conditions, sometime in mathematics when you try to do these kind of things, you actually have to create your own cases. They're different. It all depends on the relationship between A and B. Right? So what does this mean in terms of original fraction? A is greater than B. What do we say that kind of fraction? Top heavy. Top heavy. You learned the formal name in primary school, remember? Improper fraction, right? So if A over B is an improper fraction, then adding 1 to both top and bottom makes fraction what? Bigger or smaller? Smaller, right? Because this is smaller than this. And if A over B is a proper fraction, adding 1 to both numerator and denominator makes the fraction bigger or smaller? Bigger or smaller? Bigger. Are you convinced? Bigger? Yeah? I mean, this is this proper fraction? Well, bottom heavy. Yeah? And that one, did it get bigger? Bigger than that? What if we add 1 to it? So that's going to be 3/4. Is that bigger? Right. So if we keep adding 1 to both, if we start with a proper fraction, it gets bigger. What do we have here? Is it top heavy or improper or proper? Improper? Improper? Do you agree? Right? So that means which fraction is actually bigger? If it's an improper, adding 1 will make it smaller. So that tells you which is bigger. First one is bigger. You agree with that? Yeah? And in fact, let's see. You know this is very difficult to try to control the computer when you can't see the screen here. Oops. And then it's calculator, right? And say 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1 divided by 989898. Okay, somebody memorize that. Or you can jot it down before I calculate the other one. Do you have it written down? Okay, so now I try the other one. So 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros followed by 2 divided by 9898989899. Can you tell which is bigger? Okay. So it worked out. And some of you said, oh, this is, okay, we can actually figure it out this way. But is there a simpler way of doing this? Like what, can you think about a way of using what we were looking at yesterday? Well, that's what we did, right? Take it away and look at the subtraction. But what's the relationship we are trying to look at? Yesterday we had A over B like this, right? If we started as this, that's what we were doing yesterday, right? Can anybody think about a way to use this? Because we were comparing this, right? When you look at this, anything you can say?
Is it that the a plus 1 over b plus 1 will equal to c over d?
Equal c over d, or that one looks like this, right?
Yeah.
So what would the c and d be?
1.
1. So maybe what we are looking at was, well, we don't know this relationship. We're trying to figure out that thing we created, this a plus 1 over b plus 1. I think Dr. Brosnan gave you the name for this, called median. It's a median between these two fractions, right? And where would median fits in compared to the original fractions?
In between them.
In between them, right? So, and by the way, what's 1 over 1? 1, right? So here's 1, or 1 over 1. So if a over b is here, it's going to be here, right? Based on what we talked about yesterday. Is that the same conclusion as that? If a over b is that proper or improper fraction? What do you think, Michelle? Is that proper fraction or improper fraction? It's less than 1. Proper fraction, right? And if it's proper fraction, it gets bigger. It's closer to 1, right? But if a over b is in this side, this is going to be going here. It's getting closer to 1 either way, but because starting point's different, it can get bigger or smaller. Does that make sense? Would that be simpler? Yeah? No? Yeah. Well, I guess it all depends on whether or not you know about this, right? So most of your classmates back home in your RD, they probably haven't seen this relationship, so this idea they can't use. You guys can use it because we talked about this, right? Is there even simpler way of doing it? Well, maybe not necessarily simpler, but anybody have younger siblings? Yeah? How old? 13? Okay. So 13 would be what?
4 years younger.
What grade level? Is that first?
Second year.
Okay. So grade 7? Okay. Anybody else with younger siblings? Yeah? How old?
14, 9, and 7.
Okay, 9 will be, what, 3rd grade-ish? 3rd? So they haven't done the fractions quite yet. Let's say 4th graders. Do you think 4th graders can figure this out? Well, maybe let's say 5th grade. That would be 11, 10, 11, something like that. Am I okay? Yeah. And maybe even the 7th grade, so 13-year-old. Do you think they can figure this out? without using any fancy algebra. What kind of fractions do we say? So we had improper fractions and proper fractions, right? And which kinds are these? Improper fractions. How else can we write improper fractions? Same fractions, but different way of writing the same. No. Mixed fractions, right? Can you change those three fractions to mixed fractions? We'll see. Yeah, you divide it, right? And you have that result was 1.0102, blah, 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 blah. That tells you what? The whole number part of the mixed number will be 1. And what will be the fraction part? So if you're doing that, you have to, if you imagine doing the long division, you put 1 as the quotient. You see 1, 0, 0, 0, 0, 0, 0, 0, 0, 1. Then 1 times 9898, so it's going to be, you subtract that, right?
The difference between the two numbers, is it?
Yeah, so what would that be?
Not sure.
Oh, okay. Yeah, it's kind of messy, isn't it? But would the difference stay the same? Well, let's just figure that out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, and 9, 8, 9, 8. Right? And on the other side is 1. So we learned this way back in, well, you didn't do this in second grade in this big numbers, but this will be what? What's the ones place? What? You forgotten? It's been so long. So you have to do those crossing outs and all that. Okay. So it's all these becomes 9, 9, 9, 9, 9, 9, 9, 9, 9, right? So this is 3, 0, 1, 0, 1, 0, 0, right? How about this one? It's the same, right? Because he added 1 to both. So it's going to be 3, 0, 1, 0, 1, 0, 1, 0, 1. So what's the first? So it's going to come in here. And this is going to be 9, 8. And this will be 1 and this over. So 1 is the same, right? Then we have the fraction parts. But the fraction parts have the same numerator. Do you know what happens when you have the two fractions with the same numerator? And is there a way you can tell which one is bigger or smaller?
Do you just look at the denominator?
You can tell that by looking at the denominator?
Yeah.
What do you think? Can you tell by looking at the denominator?
The denominator is bigger, would be the smaller number.
Whichever has the bigger denominator is smaller
If it's the same numerator.
if it's the same numerator.
Yeah.
Did you hear? Do you agree with that? Say it again, yeah.
If the numerators are the same, whichever has the bigger denominator will be a smaller number.
Yeah? So which fraction is bigger? Well, this is mixed number, so if this part is smaller, then that means this is actually smaller, right? So we didn't really need to use all these fancy algebra, except that subtraction is just almost as messy. Some of you may look at this and says, I'd rather do this than doing that, right? Ah. Which one? Which one is easiest? That one? So when I was growing up, you know, I was finished primary school, going to secondary school, and you start learning things like solving simultaneous equations. Remember that? Right. I think is why didn't my teachers teach this when I was in elementary school? Because I was trying to solve those problems just using arithmetic. It was much more complicated. And I thought, as you get older and study more and more mathematics, you can solve the same problems much more easily and quickly. Then I ran into a problem like this and said, well, that may not be necessarily the case. Sometimes thinking about the meaning of the fractions might be good enough to figure it out. Right? We don't need calculators even. Right? So, what do you think? Fractions. Are they weird? Yeah. They look even weirder now than before. But they're friends, you're friends, you know. When you know fractions, you can do things that you can't do with decimal numbers. Michelle doesn't believe me. All right. Let's see. We're getting down a little. Somebody was talking about you want to get out here earlier than possible. But this idea of median, did everybody get my unit plan, teachers?
The teachers would have it all on their.
Oh, okay. So your teachers should too. You know, I wrote the unit plan, lesson plans, and I included some reference in that, so you can ask your teachers. But this idea, they called median, was used by clockmakers. I read through the article and I made sense of it only about halfway. But if you start with 0 over 1, right, and 1 over 1, what's the first median? You add numerators and add denominators. 1 over 2, right? Now, you can do the median between these two. What do you get? 1 over 3. If you did this way, 2 over 3. Right? Then you can start creating a whole bunch of medians. So if you create median here, this will be 1 over 4. Between these two will be 2/5. And here will be 3/5. And here will be 3/4. This weird combination of a mathematician and this clockmaker found out if you start with 0 over 1 and 1 over 1, and if you keep doing these median, you can come up with all the fractions. And then none of these fractions you come up with here is going to be those they are all simplified fractions, meaning there's no common factors. And you can list them together, all of them. And then the clockmaker figured out, you know, when you make clocks, what they do is they have gears, combination of gears to control the movement of the long hands and short hands, because they can't be moving at the same speed, right? Because when the short hand moves this much, the long one has to go all the way around. So you have to change the speed by using gears and combination of the gears and how many teeth it has and all that kind of stuff. That relates to ratios and all that kind of things. They found that way to use this, almost like they made a table of these fractions you can create with 0 over 1 and 1 over 1 and listing a bunch of medians. And they used it as a way to approximate some of the combination of gears. how many teeth you have to have and how that changes the speed of the motions. So you can ask your teachers to read the articles and explain to you, or maybe they can give you the articles themselves. She's glaring at me and saying, don't give them any ideas. So, well, it's a little early, but is it okay?
It's absolutely fine.
Oh, wait, before you go, I want you to write your second day reflection, because that's going to be part of my souvenir from Ireland and working with you guys. I really enjoyed working with you guys. So the pictures I took with you guys, and this reflection is going to be my memento from this trip. Hey, Stephen, you don't have to write your name on because I know who that is anymore. Can I talk about this lesson a little bit after they leave? Yeah, after they leave? Yeah.
Just see what time.
Okay, so Grace.
No.
Grace Neve. Yes.
Oh, okay.
That spells like it sounds. Jasmine, Kara, and Anya. So A with that makes it sound like an O.
Just to let you know that when the students finish their reflections, well, we're obviously going to give them a huge round of applause. I think they've done more maths in the last 2 days than they normally do in about 2 weeks, yeah? But you have been absolutely wonderful. I mean, in amount of time, overtime, yeah? Overtime. We would like to thank very much their teachers from RD Community School, Miss Louise Corrigan and Emma Tormey. And you know, being teachers yourself, you know the enormous amount of organisation that went on to get the group here yesterday and today. And they also have a live lesson at the conference. So there are buses up and down from RD to UCD. So we want to thank you very much for all the work you've put in behind the scenes. Also to say, it'll be on the website, yeah, www.projectmaths.ie. If you go to the lesson study and go to our library there, you will find TADS. I don't think we had it in time to load on to this, but all of the Irish teachers' lesson proposals are on this, but the other one, TADS, will be certainly put up on the website for you, okay? And you can read all about medians. And Louise, I'll email you all about medians to read over the weekend for Monday, okay? Just a little bit of light reading for you, yeah. Tad would now like you to remain in the theatre for a while, and he just wants to talk you through the lesson that he has done, if that's okay. And then we'll break for our coffee. And the live lessons, they're going to start promptly afterwards. One of them will be in here. One of them will be in the icon and one in the Intel. The information is all in your pack, which lesson is in which one, okay?
Be like a right? Don't do that with every teacher, you know. I think some teachers are more. All right. Thank you very much. I think I got everybody's paper, right? So, all right. See ya.
At Gaelic football, I think you would agree in terms of soccer, Dundalk are good, and are they good for their maths, yes?
Okay, so maybe 5 minutes. So, any questions, comments about my big hope was, well, so when I was asked to design this 3-day lessons, and Dr. Brosnan said algebraic fractions. From that perspective, I didn't want them to be doing these in a way, because this doesn't involve any of the algebraic fraction calculations at all. But from more of the structured problem solving perspective, like Dr. Takahashi's lessons, for some of you may have observed, this question had more potential for that, because there were actually multiple ways that were in theory accessible to these students. This one was probably the hardest to apply because this is something they just looked at. But on the other hand, maybe because they just looked at it, some of them might think of that when they saw that +1 +1. But then I guess they're thinking that, you know, whenever you have fraction like this, you don't necessarily think of that as C and D being equal kind of things. So they may not have thought of it that way. So in that way, from the original idea of doing these algebraic fraction things, they responded more or less the way I anticipated. But I was hoping that some of them might think about this, but I guess this difference is kind of messy. So didn't come up from the students today. But I wanted them to see that, those ways of solving it, and not always just doing things procedurally. Sometimes if you think about the meanings, you can actually figure out the questions as well. So, any questions, comments, critiques? I'd love to improve my teaching. You guys like just these students, you don't want to speak in public. I'm not going to even hand you a microphone. If that makes.
When you posed it first, my first thought was to try and go to numbers, you know, trying to put any numerical comparison. And it was interesting that you were in the algebra first and then the numbers last.
Yeah. Yeah. I didn't create this problem. A colleague from Japan said they used this problem with their students, and it works out fine with, you know, sort of standard calculators that you have in the classrooms, that when you try to change it to decimals, that decimal turns out to be equal. But if you try to do that on your cell phone or something, some cell phone calculators, they would actually go further decimal, you know, they display a lot more digits. So you can actually tell by simply converting. So if I were really careful about and then try to figure out these functions of these cell phone calculators, I may have to change those fractions a little bit so that you still get the same decimal quotients. But with the standard calculators they have, I think they only displays maybe 10 digits. I think you have to go like 13 or 14 digits to see the difference. So, but I think that whoever originally came up with that question thought very carefully about the choice of those numbers. From this perspective, it would have been nice if this subtraction was a little simpler, but maybe it's making it complicated, push the students toward that way of doing the algebra.
say if you started by giving them that before they had done all the other stuff, they probably would have approached it numerically.
No, probably not. Yeah, but you know, sometimes I think we know from lots of math ed research that students' understanding of proofs is kind of interesting, right? If you show some, you show some proofs, and then you ask them, give them some specific instance of that. So, are you convinced this is true? And says, no, I have to check it. So that these kind of a proof with generalizations doesn't really convince them. They really need to see more concrete ones as well. So, but these students were really great. I enjoyed working with them. I heard a lot about Irish students from Professor Takahashi. He mentioned that these kids are really fun to work with, and they're willing to put out ideas, and they may be a little hesitant at first, but these guys are older than the students that Dr. Takahashi worked with, and as you probably know, the older students tend to be a little bit more self-conscious, and when you're being observed by so many of you, which I told them, they just pretend you guys are cabbages in a cabbage patch. But I didn't remind them about that today. So, any other questions? Well, I'm gonna. Well,
no, I suppose just the comment I'd like to make is, perhaps, I don't know, do you agree with me? The pace of the lesson was, say, slow.
Mm-hmm.
Maybe it would be fair to say from the Irish context we have 40-minute classes, and there is a kind of sort of a speed to get so much done.
Mm-hmm.
And I don't know, would you agree with me? We would maybe deliver classes with a lot more pace.
Mm-hmm.
But what I really enjoyed was that slower pace where the students were given a lot of space to. You know, we saw a lot of misconceptions there in how you dealt with it. It was no, that's not right, that's wrong, this is how you do it. You know, that you teased it out amongst the students themselves, so the students, they were getting there to where they needed to get to. Like eventually maybe another lesson might have wrapped that up.
Yeah, I mean, if I didn't do this part here, I think it fits within 40 minutes up to this point, maybe even less. But, you know, we all know how to do math. It's the students who need to learn how to do it, and so they have to figure it out. So I think I'm not going to stand between you and coffee and tea anymore. So thank you very much, and enjoy the rest of the conference.
I've gone out and I've spoken to the students, and they're absolutely kicking themselves when they saw that. Yeah, they're just kicking themselves. Anyway, they're gone off home now, so they are. And we'd like to thank you again, Tad, very, very much. Tad is going to stick around and go to the live lesson and so on. So if I could say, you're going to have a slightly extended coffee break perhaps, but that's okay, because you need to go down, if you weren't here last night, look at the posters and decide which workshop you want to go to in the afternoon and the live lessons, okay? Could all of the associates please stay behind, and anyone who's doing a presentation or anything today for us, please. Okay.